In this video, we are going to solve an inequality with rational functions. Now, I'm going to give you some strategies to solve a rational inequality. So I will walk you through those 5 steps as we do our example. So let's look at the example. It says we are given this rational function, r of x, which is equivalent to x minus 2 over x plus 1. We want to find the values of x that make the function greater than or equal to 0. So our first step here is to relate this rational function to 0. What did they tell us? Well, they wanted it to be greater than or equal to 0. So let's write it like that. So they want that fraction, that rational expression, x minus 2 over x plus 1, to be greater than or equal to 0. Okay, so that's your first step when I say to relate it to 0. Now our second step is to find the zeros of the numerator and the denominator. So let's pull out the numerator. The 0 is x minus 2 equals 0. You're going to solve that. You're going to get 2. Now, a numerator is allowed to be equal to 0 only if this symbol allows it. If they said or equal to, and in this case they did, so x equals 2 is an official value that we can use. Now let's do the same thing for our denominator. Our denominator is x plus 1. That is equal to 0 at negative 1. But denominators are not allowed to equal 0. So remember to kind of strike that through or say, hey, I can't use that value. So step 2 is now done. Now let's move on to step 3. Using what you found in step 2, divide the number line into intervals based on these critical numbers. So we have the numbers that we see here, 2 and negative 1, in least to greatest order, number line order. So here's our R2, here's our negative 1. And I've done this little divide it into intervals. I am going to post right here the factor from our numerator, the factor from our denominator. I have a row for each of those. If there were more than one factor on each, I would keep making a row for each one of those. And this just shows me kind of my result. This is the thing I'm looking for, okay? So I have that there. And I am ready then, after I have divided it into that, made a little what I call a plus minus chart. And then we are going to choose some test values that are in the interval that we're trying to determine if they're positive or negative. Okay, so it can be any number here that is to the left of negative 1. Any number at all. You get to decide, doesn't matter, you get to pick. Well, any number that is less than negative 1, why not jump in a little bigger here so you can see it? Why not choose negative 2? It's nice, it's easy, it's convenient. In this region, if 0's in there, that's a nice number to plug in. I'm going to choose 0. And over here, why not 4? Now, it can be any number within those regions, but I think those are decent ones to try. So what do I mean by test values? What we're going to do is we're going to take those numbers, we're going to plug them into our numerator and denominator factors. We're going to ask ourselves, did I get a positive or a negative? And I'm going to record that on my plus minus chart. So if I plug in negative 2 here, I get negative 4, that's a negative. If I plug negative 2 in here, I also get a negative. Now, if I divide that numerator by that denominator, negative divided by negative is a positive. Okay. Now let's do the same thing for 0. If I plug in 0 to this one, I get negative 2, so that's a negative. If I plug 0 in here, I get a positive. A negative divided by a positive is a negative. And then let's look at this last region here. Something bigger than 2 is what we got to plug in. We decided on 4. 4 minus 2 is a positive number. 4 plus 1 is a positive number. A positive divided by a positive is a positive. Now, once we've determined what is what, now we get to move on and analyze it. Okay, so it says choose the value or values that make the inequality in step 1 true. Now remember, the 2 came from our numerator. It's a closed-in dot because of this equality here. Any values that come from our denominator, any zeros that come from our denominator are always an open circle. We want the positives and the zeros from our numerator, so we're going to shade in the positive regions. So our answer are those 2 regions there. We can be equal to this one, but not to that one. So that's where we got all of those. Now that we know our answer on the number line, we have to rewrite that. Usually they're going to want you to write that in interval notation. So just follow the number line. So we're going to start at negative infinity, go from left to right. We're going to start at negative infinity. We're going to go just to -1, but we can't stand on there because that would give us a 0 denominator. So make that a parenthesis. And then here we can include the 2. You show that with a bracket. And then we can keep on going on and on and on forever and ever and ever. And that is to infinity. Now your infinities always get a parenthesis. The numerical values may or may not. This one got a parenthesis because it was open. This one got a bracket since it was closed. Now let's look at an application. One application that uses this is the cost function. So if we have the cost function, the cost of producing X units of a commodity, we're going to denote that with this big C of X. And then we're going to need the average cost per unit. We're going to use little c notation for that one. And that's big C, or the cost function, divided by X. Okay? So now that we kind of know what those things are, in the example, it says that our cost function is 8x plus 2,000, and it is the cost to produce X number of items. And then so the first thing we want to find is the average cost function. And then we want to know how many items should be produced so that the average cost is less than 18. Now, the average cost function, we're just going to divide our big C of X function, our cost function, by X. So 8x plus 2,000 divided by X has to be less than 18. And that would be part B. Now, we need to move now on to this step to solve that inequality. You're going to have to relate it to 0. So we're going to subtract 18 from both sides. We're going to need to get a common denominator of X. We are going to get it in that rational function form. So you'll notice I wrote it as 2,000 minus 10x over x is less than 0. So now we get to move on to step 2 here. Step 2 is, now that we have this rational function, it is related to 0. We're going to find the zeros of the numerator and the denominator. So our numerator is zeros. You're going to set that 2,000 minus 10x equal to 0. Now, it is not allowed to equal 200 because it just says less than. There was no equal to, so put a slash through it. Our denominator is just easy, x equals 0, but it's from the denominator, put a slash through it. So now that moves us on to step 3. We need to make that plus minus chart that divides our number line into different intervals. So we definitely need to have 0 on there. We need to have that 200 on there. They're both open circles because the top is not allowed to be equal to 0, and the bottom is never allowed to equal 0. That then moves us on to finding some test values. Let me show it to you a little bigger. So on the number line, we need some test values in the regions we see here. Now, we're never going to have the cost of something, or the number of items produced be in the negatives. So we will talk about that in a second. But this, I have 100 in that interval. Here I have 250 in that interval. So those are at least some numbers in the interval. Now let's test them with our numerator and our denominator. If you plug in -10, you do get a positive. If you plug -10 in here, you get a negative. Let's plug 100 into both of those. For the top one, we are going to get a positive. We would get a positive here. So a positive divided by a positive is a positive region. This one was a positive divided by a negative, which gives us a negative. Now let's do the 250. We get a negative, a positive. A negative divided by a positive is a negative. Now we want things that are less than 0. So remember, that means we want the negatives. So again, we do end up getting these values to the left and to the right. So that's why I put open circles here, and you'll notice I colored in to the left and to the right, the negatives. So what do we know? Well, that is less than 0 for values from negative infinity to 0 or from 200 to infinity. But remember, based on the context of this problem, we can't use a negative number of things we're going to make. We're not going to produce a negative number of items. So in the context of this problem, we're going to throw out that region. We're only going to use the region here. So we only want x's that are over 200. So we have to produce over 200 items so that our average cost is less than 18. Anything over 200 items produced would give us a cost less than 18. So that is a little bit about solving an inequality with rational functions, and there's an application of that. Thank you so much for watching. Have a good day.